Hi everyone, I'm Tim Kington and this is Coding is for the Birds. Daisy and I are working our way through the advent of code problems from 2021 and this is day 11. Okay, so for this problem, we have a cavern full of octopi. Octopuses? Are those both right? Each octopus gains energy and then flashes. So the energy level is between 0 and 9. The energy level of each octopus increases by 1. If they hit 10, they flash. This increases the energy of all the adjacent octopuses, including diagonals. And if that causes one of them to be greater than 9, it also flashes, and this can keep happening. An octopus can only flash once per step. And then any octopus that flashed gets reset to 0. Okay, so if something like this is incremented, these 8 are all going to flash, which is going to raise the middle one's level 8 times to, it already raised once to 2, and then it gets raised 8 more to 10, so it's also going to flash eventually. So in step 1, all 9 of these flash. All right, I think this makes sense. Now we've got a bigger example, and then we need to count the total flashes. So as I said in day 9, we're going to be processing a grid of numbers. This is a thing we had to do then. So we should probably put some of this code in some utility functions so that we can reuse them more easily. I'm going to go ahead and create a util class and then move some of this code. So we'll say int array read grid maybe. Oops. And I guess lines will be passed in. And then we'll return a grid. So that's a nice thing to have. What happened to the day 9 class? We can, I guess, do this also. We'll give it a scanner. Return lines. That's kind of handy to have around. It would be nice to have a get neighbors function. So let's do that. We'll make this a constant. The reason I'm doing that is we're going to want to have maybe just orthogonal and maybe diagonal offsets, right? This octopus problem, we're going to have diagonals too. And then we want to process the neighbors, right? So we're going to do something like this. So this will return a list of neighbor points, I guess. Array of points, list of points, I guess a list. Get neighbors. We'll pass in a point. And we'll pass in our offsets, which is int offsets. And we'll call this orthogonal offsets. Okay, so this is PT, I guess. So we're going to add the offset. We're going to check our grid length. So we need either our grid size. I guess we'll say int width and height. And so we'll say if this exceeds the width, if this exceeds the height, continue. So we're going to have a list of points, list. And then here, if they're not out of bounds, we're going to add it. Okay, so what's it unhappy about here? Why didn't it resolve that? Did I miss a... It seems to me like the syntax is right. I'm doing something wrong here. Oh yeah, here we go. Why can't it just resolve this for me or ask me which class I want to use? It's not doing it. I want the AWT point. And this is points, I guess. Oh, that's why I can't figure it out. I still had another error, but it's showing me the wrong error. Okay, so we got to get neighbors. That'll be handy. So let's go ahead and work on 11. So we've got a main method here. We're going to do an index close. We're going to use day 11 text file. And then we'll say int array grid equals read grid lines. We need to read the lines. So list of string lines. Read lines. And then we're going to say int flashes is 0. And then how do we know when to stop? 100 steps. Okay, and then we're going to go through and add to our cells. So length, y. We could even make that a utility function, but that's probably going too far. Okay, so we're at a cell. We're going to add to it. So I guess we're only going to do that if it's less than 9, right? So if grid xy is greater than 9, then we won't do anything. It's already flashed, right? Otherwise, we're going to say grid xy equals grid xy plus 1. And then if this is large enough, we kind of want to handle it. We're going to want to sort of handle it recursively, or we're going to need a queue of things to process. I guess doing it as a function is pretty good. So we'll just say if grid sub xy is 10, and we're going to say flash cell new point xy, and that's fine. Okay, so now we're going to have a flash cell function. So this, we're going to need our grid to be a member or static or whatever. So when we flash a cell, we're going to go through and add to all the neighbors, right? So we're going to say for point neighbor in util.get neighbors, and we pass in p. Our width is grid.length. Our height is grid sub 0.length. Offsets is util.orthogonal offsets. No, actually, we need diagonal offsets. And then we're going to process each of those. So grid has to be up here. And we won't need to declare it here. We need to import our point class. I don't know why it won't do that for us. And then we need to create diagonal offsets in our util class. So we need some some more here. So we're going to have a -1, -1. We're going to have a -1, 1. We'll have a 1, -1, and a 1, 1. And this is called diagonal. Is that not public? What's the problem there? Cannot be resolved. What is util? Did I just misspell it? I did. Okay, so for each neighbor now, we're going to increment the neighbor. So if, okay, so if grid sub n dot x n dot y is greater than 9, we've already dealt with it, so we'll not do anything. Continue. Otherwise, we're going to add to it. And then if it's greater than 9, then we're going to flash this cell too, right? So we already have the point, don't we? And if this is greater than 9 or equal to 10, I guess, right? Is this going to work for each neighbor? I think this is going to work. And flashes needs to go out here now so that we can count them. And so here, I guess we'll say flashes plus. This could have just been a plus plus. Now, we're not going to process cells twice, right? So if we're greater than 9, we just skip it. So I think this is probably going to be okay. It's not going to go off into some horrible recursion. Let's go ahead and run it and see what happens. Okay, I forgot to print out my flashes. That seems pretty unlikely. I find 100 to be impossible. So let's try it here, maybe? We can see what's happening to flashes as we go. Yes, okay. I know what's wrong. We're not resetting our cells back to 0. So after we go through and do all the flashing, we need to set them all back to 0 if they're greater than 9. Okay, so if grid xy is greater than 9, then grid xy equals 0. So that should print something other than 100. Okay, 1713. Maybe. All right. Flashes seem to be synchronizing. All octopuses flash simultaneously in step 195. What is the first step during which all octopuses flash? Okay. Well, we know we have 100 octopuses because of our problem last time. So I guess we can say here old flashes is flashes. And then after we go through and flash them, we'll say if flashes minus old flashes is 100, then we're going to do a sys out I, and we're going to exit. Old flashes is flashes. Go through, add to flashes. Did they never flash simultaneously? Oh, we have to go past step 100. That's the problem. Okay, yes. So this is just going to be like, I don't know, just make it 1,000,000. We could make it an infinite loop, but 501 was I, which means it was probably step 5. Wait, if I is 501, that's step 502, right? Yeah. So on this problem, having the code from day 9 helped out a bit. We managed to refactor that so that we didn't have to write as much code for parsing the grid and finding neighbors. And now we have some nice methods in our util class that we'll probably be able to use again on some of the later problems. The main concern on this problem is to not let octopi flash, or octopuses flash twice on the same step, and also not to wind up in an infinite recursion. It would be pretty easy to, when an octopus flashes and you look at its neighbors, and then one of those flashes, to go back and make the original octopus flash again and get stuck in a loop. So there were 2 ways to avoid that. One was that we didn't increment an octopus's value if it was already greater than 9. And the other is we only flash the octopus when it's exactly equal to 10. Probably either of those would have stopped us from running into trouble. That was probably a belt and suspenders kind of approach. And as long as we avoid those problems, this isn't so bad. Thanks for watching. Don't forget to like and subscribe.